Earlier, I asked you all what are some movements of the earth that you know of. And we were saying probably it was rotation and revolution because those are the most common ones. Well, today we are going to look at three other movements that are not well known. It's called precession, nutation, and barycentric motion. So we will look at all of those individually. The first one we're going to look at is precession. Precession is a very slight movement that takes 26,000 years. So it's very, very, very slow, and it's not going to be moving very far. This is when the Earth's axis points in different directions. Now, this is key. The Earth's axis is pointing in different directions, okay? When you have the Earth, its axis is not going to change angles. It's only going to change the direction it's pointing. Now, I know I'm not there to watch all of you actually do this and force you to do it, but I would like it if everybody would get their arm, put it straight out, and point to one corner of the room. Well, precession would be if you move your finger from one corner to the room over to the other corner of the room without ever changing the angle of your arm. Okay, that's what precession is doing. It will point to a star called Polaris, which you do not need to remember, but it will point to a star called Polaris, and then over the course of 26,000 years, it will slightly turn to where it's pointing over to a different direction. Again, the angle does not change, okay? The angle or the tilt of the Earth, that does not change, okay? It does not change. The only thing that is changing is the direction it's pointing in. It also has no effect on seasons. It's such a small movement, it is not affecting the seasons. And this part that I have here in red is very important. It's caused by the gravitational pull of the moon and the sun. So we all know that the moon revolves around the Earth. And so when that happens, you have the Earth right here. The moon does not go straight around it. The moon's orbit is actually tilted. We call it a tilted elliptical orbit. So because the moon's orbit is tilted and because of where the sun is, just the way that gravity is pulling on the Earth, that's what causes it to have that very slight movement where it points in different directions. So the moon's orbit, okay, there's the moon. The moon's orbit is a tilted ellipse, and so as the moon goes around the Earth, because it's tilted, it is pulling on the Earth, causing the axis to point in those two different directions. So that is precession. So we know rotation, spinning in place on its axis. We know revolution or revolving, which is where it's orbiting. So that'd be like if you got up and you walked around your desk. And now we know precession. The axis is changing directions. So let's look at another movement. This other movement is called nutation. Everybody say nutation. Okay, this is the oscillatory movement of the axis. Now, I can barely say oscillatory. If that is a word that you want to go ahead and practice saying, go for it. But a simpler word that you can use for this is simply wobble. So, and you all know the song or the dance doing the wobble. I'm not going to make you do that, but I like to think of a penguin because the penguin kind of waddles. So I think if I had a mutation, then that would cause me to wobble when I walk, okay? So mutation sounds like nutation. So if I had a mutation, that would make me wobble when I walk. So nutation is causing a wobble within the Earth as precession's going on. So nutation occurs during precession, and it takes 18.6 years. So within that 26,000 years that precession is going on, changing, you get this slight wobble movement, okay? So as the Earth is pointing in this direction, or the axis, and then it points in this direction, that would be precession over 26,000 years. At the same time, the Earth is also kind of wobbling while it does that, and that's nutation. So every time it goes up, 18.6 years, 18.6 years, 18.6 years, 18.6 years, and so on until you hit 26,000. So the Earth is wobbling as it's going through precession. Now, on the center of your desk, you should have some pennies. And no, you cannot keep my pennies. Please don't steal my pennies. That would be very sad. But everybody get a penny, and then you can pause this video and you're just going to spin the penny. Now, when you spin the penny, as the penny starts to slow down, you're going to see it kind of wobbling before it collapses. That is an example of nutation. So go ahead and pause the video, get the penny, and you can observe nutation in the penny. Okay, so hopefully you've returned all my pennies and you have seen nutation in action, the wobbling of the penny. So let's look at our last movement. The last movement we're going to look at is the barycenter, aka barycentric motion. Barycentric motion is simply the center of mass. Now, I usually abbreviate this because it's so much right as a capital C, capital O, capital M. But one thing I want you to notice, whenever I do abbreviations in my notes, and this is a skill that you can use as well, I always write the word out the first time and then in parentheses put the abbreviation that I make up in all caps. That way, if I'm going through my notes, I'm like, COM, what the heck did that stand for? Well, I can always flip back and find it. So if there's a word that you know we're going to be using a lot, or a word that you just don't know how to spell so it slows you down, then you can create an abbreviation for it, but make sure that you do have a note of what it is. For example, a capital E is something I made up in college, actually high school. And to me, a capital E means energy. And so you'll notice as we go throughout the notes, whenever you see capital E, mainly in our next unit, that is always referring to energy. So that's just a quick note-taking tip. But barycentric motion is simply the center of mass. So it's a point of balance between two objects. So think of two things that's orbiting one another. Okay, hopefully you can think of at least two examples. The moon orbiting the Earth and the Earth orbiting the sun. So if you have the Earth is a lot larger than the moon. Okay, the point where they balance each other out is actually going to be closest to the Earth because the Earth is so much larger. So that would be the point of balance. You could think about it if you have two people standing up holding hands. One person that is a lot taller and weighs a lot more than another person who's a lot shorter and weighs less. If they were to lean back to balance each other out, then the person who is smaller can lean a lot further back without offsetting that person's balance. So when you have barycenter, the center of mass is always closest to the largest, or the object with the largest mass. So technically, we always say that the moon orbits the Earth, but technically they don't. They orbit its center of mass. So we always say that it's the moon that's going around the Earth, but really what this moon is orbiting around is the barycenter, so around this point right here. The Earth is also orbiting that same barycenter, but because the barycenter is within the Earth, it barely looks like the Earth is moving. For the Earth to get around this point right here, all the Earth has to do is basically kind of sway in a little circle, while the moon would have to get up and actually go all the way around. So the moon is the most obvious thing moving, but technically the Earth is moving as well. Because the movement is so small and so slight and not even very noticeable, we never actually talk about it. But anytime you're looking at the barycenter, both bodies, both planets, planet and star, whatever you want to look at, they are both orbiting the center of mass, the barycenter. So when the Earth goes around the sun, technically it's not just going around the sun, it's going around the barycenter. And at the same time, the sun is also going around the barycenter. So does that mean that the sun is stationary? Well, no. We won't get to that slide yet. The sun is not technically stationary because it's also going around a barycenter. So I do have a cool little video for y'all to watch that. The guy has an interesting accent, but he has a tennis ball and a lead tennis ball, and as he throws them, it shows you this barycenter in action. So pause this video and then switch over to that other link, and then we will resume our notes. Hopefully that video helped you to see or visualize a little bit more of barycenter. As you discussed what the key points of the video was, I just want to go over to make sure that we did hit them all. So let's see. Again, so the sun is not stationary, okay? Neither is the earth as the moon goes around it. Everything is orbiting its barycenter. I wanted to show you these pictures to make sure that you could kind of see this, but when you're looking at the sun, remember the earth is not the only thing that's orbiting the sun. You also have all these other planets that are within our solar system. So when all of them are pulling on the sun and creating a barycenter, the center of mass is almost dead center with the sun. You can see it like averaged right around here. So when I say the sun is barely moving, I mean it's barely moving. If you swayed in little tiny circles in your chair, if you could make that sway the least noticeable possible, that would be like how the sun is moving. But technically, no, the sun is not stationary. This picture over here is simply showing you where the barycenter is of just the earth and the sun. But remember, there are other planets that are also affecting the sun. But that is with its center of mass. The other main things with the video is just to remember that it is always closest to the object with the largest mass, and that's where the barycenter is. So let's move right along. We are now going to do some trivia. Got to make sure that we are doing constant review because I know that we've learned a lot already, and I want to make sure that you do remember it. So we are going to end this video so you can do a trivia review. Have fun, and I do have some candy for whichever group wins, so do your best.